Why do they call it a black hole? It's the most destructive force in the universe. It's not actually a hole, but it's powerful enough to tear apart stars, devouring everything that comes near it. A terrifying beast that can even warp time and space. So how exactly does a black hole bend empty space? Will it exist forever in the universe? When astronomers first discovered black holes, what surprised them the most was a black hole can actually trap light, and it can even bend space-time. So how did he manage to do that? Let's imagine this. When you throw a ball, it falls back to the ground due to Earth's gravity. To us, the ball's path is a curve. But in reality, the ball follows the shortest path in space-time. It's moving in a straight line through space-time. Time and space itself actually bend. The mass of the Earth can bend time and space too. Because the greater the mass, the greater the curvature, the trajectory of the ball becomes more curved. In fact, when a celestial body's mass reaches a certain level, the bending of time and space becomes extremely intense. Even light can't escape its gravity. That's a black hole. In 1783, British astronomer John Michael predicted the possible existence of a dark star in space. He believed it to be a massive celestial body with an escape velocity equal to the speed of light. However, this idea didn't really catch much attention at the time until Einstein's theory of general relativity emerged. It was then that German scientist Karl Schwarz discovered a solution to the theory of general relativity. This solution describes a possible dark star, what we now call a black hole. Even Einstein himself never imagined that this lady could get it so easily. He was incredulous at this peculiar celestial body. As time goes on, evidence gradually accumulates. Black holes also start appearing in human sight. In 1971, the astronomer, we discovered the first black hole in human history. It's called Cygnus X1. The presence of this black hole provides the first piece of compelling evidence. Since then, we've been accumulating evidence supporting the existence of black holes through various observation methods, such as X-ray binary star tidal disruption events, gravitational wave astronomy, and direct imaging technology. Now we know supermassive black holes seem to be located at the center of every galaxy. They are essential giant objects in the universe, providing a crucial guarantee for the operation of galaxies. Ever since humans discovered black holes, one question has been lingering in the minds of scientists: whether black holes will exist forever. We used to think that black holes would exist eternally, but now, Stephen Hawking's research changed that whole perspective. Hawking discovered, according to quantum theory, black holes aren't completely black. They slowly evaporate. That's the famous Hawking radiation. When an object enters the gravitational range of a black hole, it gets devoured by the black hole. This gravitational range is also called the event horizon. The incident, the vacuum around the world, isn't truly empty. According to Heisenberg's uncertainty principle, particle pairs will spontaneously be created here. These particle pairs usually annihilate each other in a very short time, and then vanish without a trace. But if a pair of particles happen to appear on opposite sides of the incident world, one particle might fall into the black hole. The other one might be able to get away. From the outside looking in, a black hole is like radiating energy. According to the intelligence formula, 1 equals the square of every gram. This means that the black hole is losing mass. As time goes on, the black hole will gradually lose mass, eventually heading towards death. In other words, black holes won't exist permanently. He's also got a day of reckoning coming. Could that black hole be like a baby universe? Maybe the black hole could flip into a white hole. spitting out matter and information? If that black hole is like a baby universe, then what about our Earth, or even the whole universe? Could we be inside a super giant black hole? Actually, there are quite a few people who believe so. Black holes might actually be wormholes to other places. So, the idea of tiny wormholes existing has been brought up. The idea of a law was also raised. Maybe examples of things falling into black holes could be explained by events. Tiny wormholes inside the event are brought back. That's why we see Hawking radiation. Some people also believe matter is lost in our universe, but on a multiverse level, it's still preserved. Isn't that just incredible? Many people might wonder, how many types of black holes are there? Well, black holes are actually classified based on the different masses of black holes. Astronomers classify black holes with less than 100 times the mass as stellar mass black holes, and those between 100 and 10,000 times the mass of the Sun are called intermediate mass black holes. When a black hole's mass exceeds 100,000 times that of the Sun, it's called a supermassive black hole. Stars and black holes are formed from the death of massive stars, are a widely existing celestial body in the universe. Take our Milky Way, for example. There could be as many as several tens of millions of stellar black holes. However, the formation mechanism of intermediate mass black holes is still unclear. Astronomers speculate may be formed by a bunch of top-tier black holes merging together. While supermassive black holes sit at the center of galaxies, they're massive in size, playing a crucial role in the formation and evolution of galaxies. You can think of them as the engine of galaxies. Without them, galaxies would fall apart. The mysterious thing about black holes is, we can't see them with our naked eye at all. So how did scientists even observe black holes? For over half a century, the astronomers carefully have come up with various ways to search for black holes, including the X-ray method, detecting black holes, attacking the X-rays emitted by the companion star material. And there's the gravitational wave method, detecting two black holes, emitting gravitational waves as they orbit each other. And then there's the velocity method, detecting the Doppler motion caused by the companion star orbiting a black Doppler motion. Astrometric method is used to detect the periodic positional changes on the celestial sphere caused by the companion's periodic changes in position on the celestial sphere. Gravitational lensing refers to detecting a black hole passing in front of a background star, causing changes in the star's brightness. Each of these methods has its own advantages, but they can help us understand better the nature and behavior of black holes. If a star unfortunately gets too close to the black hole's gravity acts like an invisible giant hand, firmly grabbing the star, suddenly pulling its outer gas into its gravitational trap. Right after that, the black hole's tidal forces start to show their power, tearing the star apart like shredded paper. The whole process was both brutal and magnificent. When early astronomers observed this phenomenon, they were too excited to put it into words. No one saw this coming. There exists such a terrifying celestial body in the universe. What's even scarier is, the more advanced our observation equipment gets, the more black holes we discover, and they're getting closer and closer to our solar system. Maybe not far from our solar system. There's a superstar black hole out there. We just haven't discovered it yet. For us humans, black holes hold too many mysteries, waiting for us to unravel. Currently, multiple teams of scientists have proposed trying to create a mini black hole in the lab. But the energy scale required far exceeds our capabilities. We can only simulate the characteristics of a black hole through optical means, rather than actually creating a gravitational black hole. Nevertheless, our research into black holes will become increasingly in-depth. It can be said that the emergence of black holes has challenged our fundamental understanding of it. May even subvert our comprehension of the physical world. Perhaps one day, we may truly unravel the mystery of black holes, the ultimate mystery of the universe, finding the unified theory of everything.